the first thing leading up to working with the equations of a line is to be able to calculate and identify slope. Okay, so the slope of a line has one of four tendencies. Okay, so one is the slope goes up and to the right. If that's the case, it's going to be a positive slope. Okay, if the away. All right, if the slope goes down and to the right, it's going to be a negative slope. Right, if it's a horizontal line, meaning it's flat, it's going to have a slope of 0. And if it's a vertical line, it's going to have an undefined slope. And so those are the four kind of possibilities when you're dealing with slopes. Okay, and the slope can be visually counted. If you count it, the letter that represents slope is a lowercase m. So if you visually count it, it's going to be the rise over the run of your graph. The rise represents a change in the y values. So this symbol right here, it's delta angle with kind of like a shaded edge to it. Delta y means the change in the y's over the change in the x's. And so calculation-wise, that is the difference between their coordinates, y1 minus y2 over x1 minus x2. And you could put the variables in either order. You could start with y2 minus y1, but whichever y coordinate you begin with in the top of the calculation, you need to start with the same that coordinates or that same point's x coordinate. And so this is how you would calculate and count your slopes. And so I want you to try using that calculation here to come up with the slope of this problem right below, please. All right, so sometimes calculating slope is the first part of writing an equation. And so you either need to be able to count it visually or calculate it with an equation. So here, if we use the equation to solve this first one, the slope is equal to the difference of the y's. Again, it doesn't really matter which one you start with. Just make sure you start with that corresponding x coordinate. So 6 minus the other coordinates y, a negative 4. Notice I keep track of the signs. And because I started with the first point's y coordinate, I need to start with its x coordinate as well. So negative 6 minus the 10. And now I can simplify what's happening. When I subtract, subtracting is equivalent to adding the opposite. So I get a positive 10 over negative 6 minus 10 is a negative 16. Simplify what I have. The negative's always written either in the numerator or in front of the fraction. And so I can reduce this. 2 goes into 10 twice. 2 goes into 16 8 times. So I get negative 2, or sorry, 2 goes into 10 5 times, 2 goes into 16 8 times, and so I get a negative 5 over 8 for my slope. Now, I could also have just entered my calculation too, right? If I entered this, I would get my solution right here in the decimal form to equate that. But you should be able to enter your answer as a calculation when you're entering the slope. In addition to this, you can also find the slope by counting. Okay, so see if you can find the slope of the line drawn to the right. Yet how to count it, but I'm kind of waiting to see if you remember this from algebra. Okay, but it's based on that definition of rise over run. And so the key to this is you need to find 2 points on your graph that meet right where the grid lines intersect. You want it to be numbers or values that are integers with no issue with like that with precision that that's your point. So here's 1 point, 0 4. Here's your other point. If you look right here, negative 4, negative 1. Now you could, if you're more comfortable calculating, you could use these two ordered pair and calculate the slope. But the easiest thing to do is just count rise over run. So here, if you go from the bottom point up, you go up 1, 2, 3, 4, 5. So a positive direction is a plus 5, and to the right you go 1, 2, 3, 4 places to the right. So your slope here is 5/4 if you calculate it that way. Now you could have also, I'll use a different color and go from the top point down. If you go from the top point down, you go down 1, 2, 3, 4, 5. So that's a -5. And then you go over 1, 2, 3, 4 toward the left. Oops. So over 4 to the left. To the left is in the negative direction. The negatives cancel, and you'd still get your answer of 5/4. And so that is your slope. Counting it often, especially if you have a graph there, counting it is going to be an easier process. All right, so these are examples of, here we see a positive slope, here we see a negative slope. So what's going to happen when we have those vertical and horizontal lines? So let's take a look at that next. So remember, the horizontal line is one where the slope is 0. Okay, but what's consistent here is a horizontal line is always going to have the same y value. So any point along this line, it's going to have the exact same y value. So the equation that represents a horizontal line is just going to be the form y equals b. Yeah, I chose, or b is chosen because that represents the y-intercept in a slope-intercept form. Okay, and this is a consistent. This can be written as the y equals mx plus b, where your m value is 0, giving you that equation, y equals b. So really all the points on here, x1b, x2b, no matter what x coordinate you choose, the y coordinate is going to be a b. When you look at a vertical line, the vertical line is set up where the slope is undefined. But when you look at all of these points here, the x coordinate never changes. So the equation to represent a vertical line is just x equals a, some constant a, where you have the points a, y1, a, y2. Again, any point along that line is going to have the exact same x coordinate when you represent that. All right, so let's start here on the right-hand side. I want you to see, can you answer the question on all 3 of these graphs? And can you write the equations, or sorry, here you're writing the slope. Can you identify the slope of all 3 of these graphs? If you have a slope that is undefined, you're going to enter it as DNE, does not exist, for the MyOpenMath entries. Okay, so what's the slope of this first problem here? This vertical line has a slope of undefined, so DNE. Part B, this horizontal line has a slope of 0 is the horizontal line. And now this next one, you actually need to go in and again, find points that fall on here. You might need to zoom in. Check the y-intercepts first. That's usually like a good point to start with. And then as you start to look, I mean, it looks like this one is close, right? But if it were, then this next one would also fall on a grid intersection, but it doesn't. So you know it's not going to be a slope of -1. So what you need to do is you need to kind of continue to extend until you find one that looks like it's consistent. And you should see that right here would be one, the next one that you find. Okay? And so if you go from one point to the next, from -1 to 7, this goes up 8, and from 0 to -7, this goes left 7. And so what you see here is your slope is going to be a +8 over a -7, right? The rise over the run. And so -8 over 7 is going to be your solution for that. So counting your slopes when you're looking at the graph. Okay? If you're looking to write the equation of these lines, again, you're looking for the form y equals b or x equals a. And sometimes what you're looking for is, do the x coordinates not change? Do the y coordinates not change? Okay? And so it may be that you're asked to write a vertical line through a given point, or you may be asked to find the equation based on the two ordered pair. So I want you to see if you can answer these two questions here. So these two questions kind of illustrate what those possible ways that you might be asked to write a line, a vertical or horizontal line. And so this first example here, it says find the equation of the line passing through those points. So as we start to get into the process for finding equations of lines, the very first thing that you generally do is you find the slope, and then you use the slope to calculate the rest of the line. Well, before you even get to that, the first thing you should do is look carefully at the points. Do they have the same x-coordinate or do they have the same y-coordinate? Because if that's the case, here an x of 14 and an x of 14, all you need to do is write that the x is always 14, and that is in equation form, x equals 14. Now, sometimes it won't give you that, and if that's the case, you go through the normal process for writing the equation of a line. But look to see, is it a vertical or horizontal line first? Next here, the second example that you might see would be find the equation of a horizontal line. So you know the horizontal line is going to be of the form y equals. And so if it tells you what one of the points is, all you have to do is focus on the y-coordinate in this case, because you know that the y's are always the same. And so here the y is going to equal 6. In the second example or cluster of question here, you see find the equation of a line passing through 2 points. Just look to see the x's are different, but the y's are the same. That means the y's are always equal to 7. This is for linear equations. And then the other one, find a vertical line. Vertical line has the form x equals a, so you can write the x equals part, and then just focus on the x-coordinate, which in this problem is 0. And that would be your, those would be your equations for these problems. All right, questions on those? All right, so the rest of this, the notes here are going to be about finding equations of lines. And there's 3 different forms that you can write that you'll see equations of lines written in, or that you can use for them. I'll talk about all 3 of them, but we're going to kind of focus on using just 2 of them. And the first one is point slope form. This is very useful when you're given a single, just like what the word says. If you're given a point and the slope, this is a really useful form for writing the equation. And let me first derive it. If you write the equation of slope, so here, if we say that we have y2 minus y1 over x2 minus x1, if you take this equation for slope and you just get rid of the fraction, so we cross multiply here. If we cross multiply, we take 1 times y2 minus y1 is equal to m, so that's this, m times x2 minus x1. If you then just remove this subscript, you get your point slope form. This is your point slope form. Point slope form is just a rewriting of the slope equation. Okay. So this is useful when you're given a point as xy and you're given a slope of m. Okay, so if you're given that information, you can, unless it asks you to put it in a different form, you can enter your answer just like this. So look at this first example right here. Okay, they gave you a point, they gave you a slope. Specifically, they told you to put it in point slope form, but even if they didn't and they asked you to write this equation of this line, you can use point slope form and just plug it in exactly as appears in this boxed form. And so I want you to write what you think that means before I go through it. So again, I want to see if this is intuitive to you before I explain what it means and where these pieces go. So really the points based on this are going to be x1 and y1. You're going to substitute the values that you have for one of your points into the x1 and y1 parts of that function or that equation. So really all you're doing is you're plugging it right into these spots. So we take y minus our given y, which is 2. is equal to our given slope, which is 5/7, times x minus our given x, which is -8, minus a negative becomes a positive. So all you would have to do is enter your answer in that form. Okay, so see if you can do that with this graph right here. So in this graph, they gave you a point. They don't give you a slope, but they give you the equation of that line. So you can use that equation to find and calculate or count your slope, and then see if you can plug it into point slope form from that. When you're counting slope, if that's what you're choosing to do, you need to find, if you can, you need to find more than one instance of it to verify that you're counting it correctly. Because sometimes it looks like the graph crosses at a grid intersection, so you might go like up 3/2. But if you go up 3/2 again, you'll see for sure that that point or the graph does not fall on the grid markings. So you might need to adjust your counting based on that. So try to count as many instances of the slope, the rise and run of a slope, to verify that each time you do it, it's landing right on those intersection of grid marks. Okay, because just by looking at this problem here, we have our x and we have our y. So we can use the point slope form, y minus our y value 1 equals, I'm going to leave a space for my slope, x minus our x value of 1. So I know this, and all I need to do is fill in what is the slope. So I'm going to zoom in here to see it a little more easily. And I can see right here, it looks like I have a grid intersection. My graph crosses that grid intersection. Now, as I go through, like right here, looks like it's close, but if I go down 2/1, down 2/1, I see that this is where it would have been if that was correct, and it's not on that mark. So I can assume that it's not down 2/1. So if I continue to move down here, this one looks close, but this one right here looks even closer. And so if I count from one to the next, I go up 1, 2, 3, 4, 5, 6, 7, 8. And I go over 1, 2, 3, 4, 5. And if I look to see now, is this my slope? So if I go up 8, so from 1 all the way to 9, so there's going up 8 again. And do I go over 5, and does it look like that lands right on an intersection? Yes. If I go down 8 and over 5, does that land right on an intersection? Yes. So what I can see here is that by counting, my slope is up 8, left 5, so it's a negative. When I look at this, it's -8 over 5 for my slope. Questions on that using point slope form? Right. So the last scenario is, what if they don't give you a graph, but they gave you 2 points? Okay, is there enough information that you can find here in order to write an equation in point slope form? Okay, so see if you can find the equation of this line in point slope form. Notice here are your 2 steps. Okay, you can find the slope. If it's easier for you to plot it and count your slope, you can do that. If it's easier for you to calculate it, which for me, in this case, I would just calculate the slope is equal to the difference of my y's. So 2 minus 6, I'm just going to use the first point. This is the point I'll use first. Over the difference in the corresponding x's, so the starting x is 10 minus a -8. Subtracting is equivalent to adding the opposite. So I get a -4 over 18, which can be reduced, take a 2 out of each, -2 over 9. So here is my slope. And so all I need to do to write my equation is take my point slope form, y minus one of my y's. I'm going to go ahead and just choose the 2, since that's the point I started with, equals my slope, -2/9 times x minus the corresponding x, which is 10. And that would be my solution. Now, this is not the only equation you can use, because you could choose either of those 2 points. When you select x1 and y1, you could have just as easily done y minus the second point's y coordinate 6 is equal to the slope negative 2/9 x minus the first or the x coordinate of that second point negative 8. And so this would have also been an acceptable answer. These will give you the exact same line. Now, the next thing that we're going to talk about, so for me, I guess I was taught to use point slope form. I always use point slope form. Okay? As I've been teaching, that disappeared pretty quickly, and students rely more heavily on using slope intercept form. And I don't care which one you use. If I had to write this equation in slope intercept form, I would still solve it this way, and then I'd just solve for y. And so I'd get rid of my grouping symbols, move the constant over, and that's going to be my slope intercept form. So you can still take point slope form and turn it into slope intercept form just by expanding and combining like terms and isolating the y, solve for the y. But most students that I found do prefer to use slope intercept form when they're writing equations and working with equations. It's up to you, whatever you would like to do. Again, when you are being asked to write an answer for the equation of a line, if it doesn't specify, you can choose either one. And point slope really is a little more efficient in this case if you want to do it that way. But here is slope intercept form. Slope intercept form is y equals mx plus b. Again, where m is your slope, b is your y-intercept. It means it's the value on your graph when x is 0. It's whatever the corresponding value is. And so if you're going to be solving or putting problems in slope-intercept form, so point-slope form works great if you're given a point and the slope. Slope-intercept forms works the easiest if you're given what the word says, the slope and the y-intercept. Okay, so if you were just asked to interpret the slope-intercept form, I want you to answer this first question really quickly. Should be something that you can do almost instantaneously. Just make sure you're following the instructions and writing your y-intercept as an ordered pair. All right, so when you look at this equation right here, it's in slope-intercept form. Slope-intercept form is found just by solving for y. Right, so if you ever need to do it, just solve for y if it's not already written in that form. Okay, and so you see that your slope is the coefficient of x, -7. Your y-intercept is the constant 4. Now, it asks you to write it as an ordered pair. So an ordered pair is written as in parentheses as an xy coordinate. Your x coordinate is 0, just like what you see right here. Your y coordinate is whatever that y-intercept is. So this would be your answer for, or your answers for this set. Now notice I wrote standard form. I told you there were 3 forms that you might express an equation of a line. Point slope forms, slope intercept form. Standard form happens when you put the x's and y's together on one side, and you put your constant over on the other side. And the only other stipulation in standard form is that the a, the b, and the c value are going to be integers. And they can't be fractions, can't be decimals. And so you might need to multiply all terms of an equation by some number to get rid of your fractions first, and then reorder it so that the x's and y's are on one side, the constants on the other side. So what you see right here, this is an example of standard form. Okay, so what I want you to do is, I want you to convert from standard form into slope-intercept form, and then write the given slope and the y-intercept. And so, and that's following this instruction that you saw underneath, solve for y. And so take the standard form, solve for y, and then interpret the slope-intercept form from that, please. So when you are taking a standard form and solving for y, we leave the 7y where it is. On the left side, we're going to move the 2x over, so we subtract 2x from both sides. The -17 is going to stay where it is. Now, when I divide by the coefficient of y here to isolate the y, instead of treating it as just 2 sides of an equation and divide by 7, which is still possible, you can still do it this way, but rather than treating it like that as 2 sides, treat it as 3 individual terms. So I'm going to distribute this 7 into each individual term, and that's going to give me my equation. Y is equal to negative 2/7 x minus 17 over 7. And it's just easier to interpret it this way because we see that our slope is negative 2 over 7. We see that our y-intercept is negative 17 over 7. Notice this already has the ordered pair as the x is written as a 0 here, so I just need to put the negative 17 over 7 for my answer here, and that would be my solution. All right, let's do this next problem right here. Again, it should be something that you can do almost instantaneously. If you're given the slope and you're given the y-intercept, I want you to write the equation in slope-intercept form. So here you're given the slope and you're given the y-intercept, and just plug that right in and write your equation, please. So slope of 5, we get 5x plus our y-intercept of negative 6. It already has the y equals, and so that would be our equation here. So that's as simple as it gets, writing the equation given the correct information, the most efficient information for slope-intercept form. What if it asks you to write the equation and they give you the graph? And so once again, you need to know the slope and know the y-intercept. You can do that. You can interpret that from the graph and then plug it into the slope-intercept form. So I want you to see using that graph here. Can you find what the equation is in slope-intercept form? If you're given a graph and asked to find the equation and it doesn't specify which form it wants, if you can see the y-intercept, which you can on this one, right? You see the y-intercept is 3. I would probably use slope-intercept form. If you can't see the y-intercept, or if it's a fraction, so you don't know specifically that it's not an integer value, and so you can't tell with certainty what the number is, then I would use point-slope form. Find 2 points or find a point somewhere else, use its x and y coordinate in point-slope form, and then for both of them, you're going to count the slope. So here as I look, so if you identify your y-intercept right here at 3, so you know that this is this is going to be y equals mx plus 3. You have your y-intercept. All you need to do is find your slope. So here is the grid mark that you can find. Use the rise 1, 2, 3, 4, 5. So up 5 over 1, 2, 3, 4 to the left. So our slope is a positive 5 over a negative 4. Put the negative sign either in the numerator or in front of the whole fraction, and you get your graph. Now, don't just use the one case of this, right? You need to confirm that this is right. So, and I find this next intersection of the line on the grid marks, and I can go 1, 2, 3, 4, down 5 over 4, and I see that the slope is in fact negative 5 over 4, and that allows me to work through or identify the correct slope or the correct slope-intercept form. All right, so let's take a look at the last kind of scenario here. We already did a problem with this, so this is nice and easy. The slope of negative 6 and a y-intercept of negative 5 just plugs right into the slope-intercept form. Okay, but I want you to see, can you write the equation of a line that passes through these 2 given points in slope-intercept form? So see if you can answer that, and again, I'll rewrite the slope-intercept form here. One possible way to do this is to solve it the exact same way you did point-slope form, and then just solve for the corresponding y. But most students that I've found prefer to solve this using slope-intercept form. So here's the steps for that, if that's how you're going to solve this, which again, most of you probably will. So step 1, you're going to find the slope. Okay, so I have 2 points here, so I'm going to go ahead and calculate that slope. I take the difference of my y, so 12 minus 8, over the difference of the corresponding x's. I started with this y, so 2 minus 4. When I simplify this, I get 4 over negative 2, giving me a slope of negative 2. So already I can fill in this part of my equation. I know what my slope is. I get y equals negative 2x plus or minus whatever my b value winds up being. So let's go ahead and solve for that b. So what we're going to do is we're going to plug in an x, a y, and an m, our slope, to find the b value, to find that y-intercept. So if I take my y equals mx plus b, I'm substituting in a given set of coordinates for x and y. I'm plugging in the slope that I just found, and I'm going to solve for the b. So it doesn't matter which point I choose. I'm going to go ahead and use this one just because it's single-digit numbers. So I get 8 for my y. My slope was a -2. My x is a 4 and plus b. So I'm going to solve for this b. I get -8 plus b is equal to 8. Isolate my b by adding 8 to both sides. And I get my b value to be 16. So plus 16 is my y-intercept. And that was my last step. This third step was to plug in the form y equals mx plus b, which I was doing like as I was going through it. And so that would be my equation. Okay? So this is how most students prefer to have been doing it for decades now. Again, I always use point slope form, but it's up to you if this is probably what you've seen and is the most comfortable for you. All right, the final question here. I want you to see if you can take a given equation and sketch its graph, again based on slope-intercept form. Basically, you're doing these steps. You're going to select the graph tool for a line. Notice there's 2 points in there. It's going to take 2 points to plot this graph. The first point, easiest thing to do is to plot the y-intercept, especially, I mean, if it's a fraction, it might be a little bit harder to do that. But if it's an integer, just plot that point. So there's the first point. And then you're going to use your rise over run to plot a second point. So if you go up like a rise of 1, a run of 2, once you get to that point, it will auto-populate or auto-fill in the rest of this line, and it will give you the correct line just from that. Now, you could have also gone down 1 over 2, so we could have gone to this point. And whichever way you want to count, up and over, down and over, will work if you use the correct signs to indicate that.